Hey everyone, welcome to section 1.3, and in this section we're going to be talking about fractions, specifically how to do operations between them. So, first of all, a fraction is an expression written a over b, where b is not 0. Now, the number a is the numerator, and b is called the denominator. And when the numerator and denominator are both integers, that's what we call a rational number. So what we're going to do is quickly go over the operations between fractions. It's easiest, I think, to start with multiplying and dividing. Multiplying two fractions, a over b and c over d, which I'll write here, boils down to just multiplying the numerators and denominators together. That is, multiplication between fractions is defined as a over b times c over d equals a times c divided by b times d. And division is very similar. For dividing two fractions, we have to first multiply the first fraction by the reciprocal of the second fraction, supposing that the numerator and denominator of the second fraction are not equal to 0. What do I mean by reciprocal? If I have the number 1 over 3, then the reciprocal is 3 over 1. So the reciprocal of a fraction is simply the fraction which switches the numerator and denominator of the original. So for some examples, first up we have negative 12 over 5 times 10 over negative 2. And again, just going off of how multiplication is defined, we simply multiply the numerators and denominators together. So that would be negative 12 times 10 over 5 times negative 2. Which is negative 120 over negative 10. Next up, we have negative 7 over 3 times negative 4x. And it might seem a little bit strange because the first number here is a fraction, and then this second factor in the product is not a fraction, but it's just a normal algebraic expression. The way that we get around this is to just simply imagine that the negative 4x is a fraction, but the denominator of the fraction is just 1. So there we get negative 7 times negative 4x divided by 3 times 1. Negative 7 times negative 4 gives me 28x divided by 3. And last example, we have 3/4 divided by negative 12/5. So for division, what we have to do is multiply by the reciprocal of the second number. In other words, we're going to be taking 3/4 times 5 over negative 12. Okay, so we multiply straight across. Like so, and then simplify. All right, so next up, we have this notion of equivalent fractions. basically two fractions that have the same quote-unquote value. So for any numbers a, b, and c, with b and c not equal to 0, the fraction a over b is equal to a times c over b times c. And this gives us a way to reduce our fractions by finding common factors of the numerator and denominator. A fraction is going to be reduced if the numerator and denominator don't have any common factors, aside from 1, of course. So for an example, we might look at something like 6 over 10. And we want to think, okay, do 6 and 10 have any factors in common? Well, they both have factors of 2. So we have 6 is 3 times 2, and 10 is 5 times 2. And according to this rule here, going from right to left, this is equal to 3 over 5. Now, you might see in another class someone do something like this to do what they call canceling. It's applying this property of fractions where a over b equals a times c over b times c. You can write it, but it's not strictly speaking necessary. All right, moving on. Adding and subtracting fractions. This is kind of unpleasant sometimes, but it's okay. You know, we're going to get through it. So to add and subtract fractions, you need to have the same denominator. Full stop. You can use any common denominator that you want, really, but oftentimes it's helpful to have the LCD, or what we call the least common denominator. For example, we have 5x over 6 minus 3 over 10. To successfully subtract these guys, I need to have the same denominator. Let's see. What's my common denominator going to be? Well, let's see. I can just take 6 times 10 and get 60. This isn't the least common denominator. The least common denominator would be 30. So to get 30 from 6, I have to multiply 6 times 5. And when I change the denominator of a fraction, I have to keep it equivalent. So I also have to multiply the numerator by 5. To get 10 to 30, we have to multiply the denominator here by 3. But again, we're keeping the fractions equivalent. So I also have to multiply the numerator by 3. So we end up with 25x over 30 minus 9 over 30. Which is then equal to 25x minus 9 over 30. That's it. We don't want to go any further because 25x and 9 are not like terms. You can't really combine them in any way. But we'll talk more about reducing expressions like this in the next video. All right, if I have 3a over 4 plus 8 over 9, to add these guys together, I need to get a common denominator. And let's see, what do I want to pick as my common denominator? Well, 36 is 4 times 9, so we can use that. To get to 36, I have to multiply the 4 by 9, but again, I have to keep my fraction equivalent. Same dealio over here. 9 times 4, also have to multiply the numerator by 4. So 9 times 3a would give me 27a over 36 plus 32 over 36. And since they have the same denominator, we can combine them into a single fraction here. And let's see, last up we have 4x over 5 plus 1 over 6. So we're just getting some practice adding and subtracting fractions, especially that have variables in them, because that's, very nerve-wracking. A common denominator for 5 and 6 would be 30. So to get to 30 from 5, I have to multiply by 6. And to get to 30 from 6, I have to multiply by 5. After doing that, I get 24x over 30 plus 5 over 30. So at the end of the day, we have 24x plus 5 over 30. And we're not really worrying too much about any simplifying. We just want to get ourselves used to the idea that we can add together and subtract fractions that have variables in them. One last thing that seems to cause a lot of confusion when it comes to fractions is the location of the negative sign. The negative sign in a fraction could be placed in a bunch of different locations. For example, if you had the fraction negative 3 over 4, that's the same as if you had 3 over negative 4. So if we think for a moment, fractions represent division, and the sign of the answer between these two fractions is going to be the same. And of course, the numbers are the same. So these two fractions are the same. And also, it's sometimes helpful to just put the negative sign out in front so there's no ambiguity. That is, the whole fraction is negative. However, I want to include a caution. Okay, and this is important. I see this mistake a lot. Like it's really, imagine it's glowing. Okay, this is a big caution. The negative sign, negative 3 over 4, for example, can go to either the numerator or the denominator. You can rewrite it that way, but not both. So under no circumstances should you say something like negative 3 over 4 is negative 3 over negative 4. Never, ever, ever do this. But I'm sure after some practice, you'll never make that mistake. And that's the end of this video.